The Nobel Prize in Chemistry is one of the most prestigious awards in the field of chemistry. It is awarded annually by the Royal Swedish Academy of Sciences to individuals or groups who have made outstanding contributions to the advancement of chemistry. The prize was established in 1895 by the will of Alfred Nobel, the inventor of dynamite, and first awarded in 1901. The Nobel Prize in Chemistry 2023 has been awarded to Moungi G, Bawendi, Brus and Alexei I, Ekimov for their discovery and synthesis of quantum dots. Quantum dots are nanoparticles so tiny that their size determines their properties. These smallest components of nanotechnology now spread their light from televisions and LED lamps and can also guide surgeons when they remove tumor tissue, among many other things. What is quantum dots? A quantum dot is a tiny particle of a semiconductor material that has some properties of a single atom. It can emit light of different colors depending on its size and shape. Difference between quantum dots and nanoparticles. Quantum dots and nanoparticles are both very small structures, but they have some differences. Quantum dots are a type of nanoparticles that are made of semiconductor materials, such as cadmium selenide or lead sulfide. They have a size range of 1 to 10 nanometers and contain 10^3 to 10^5 atoms. Quantum dots have unique optical and electrical properties that depend on their size and shape. They can emit light of different colors when excited by an external source, such as a laser. Quantum dots are used in many applications, such as TV screens, biological imaging, solar cells, and lasers. Nanoparticles are a more general term that refers to any particles that have at least one dimension between 1 and 100 nanometers. Nanoparticles can be made of different materials, such as metals, polymers, proteins, or carbon. Nanoparticles can have various shapes, such as spheres, rods, tubes, or shells. Nanoparticles can also have different properties depending on their composition, structure, and surface chemistry. Nanoparticles are used in many fields, such as medicine, catalysis, electronics, and nanotechnology. One way to think about the difference between quantum dots and nanoparticles is that quantum dots are a specific type of nanoparticles that have quantum confinement effects on their electrons and holes. Quantum confinement effects mean that the energy levels of the electrons and holes are discrete and quantized, rather than continuous and broadened. This results in sharp emission spectra and tunable band gaps for quantum dots. Nanoparticles may or may not have quantum confinement effects depending on their size and material. Applications of quantum dots. Quantum dots are nanoparticles that have unique optical and electrical properties that depend on their size and shape. They can emit light of different colors when excited by an external source, such as a laser. Quantum dots have many potential applications in various fields, such as solar cells. Quantum dots can improve the efficiency and stability of solar cells by absorbing more sunlight and converting it into electricity. Quantum dots can also be used to create flexible and transparent solar cells that can be integrated into windows or fabrics. LEDs. Quantum dots can enhance the brightness and color quality of LEDs by emitting pure and saturated colors. Quantum dots can also be used to create quantum dot displays that have higher resolution and lower power consumption than conventional LCDs. Biomedical applications. Quantum dots can be used as fluorescent probes for bioimaging, biosensing, and drug delivery. Quantum dots can target specific cells or tissues and emit light signals that can be detected by cameras or scanners. Quantum dots can also be used to monitor the temperature, pH, or oxygen levels of biological samples. Quantum computing. Quantum dots can be used as quantum bits or qubits, the basic units of information in quantum computing. Quantum dots can store and manipulate quantum information by using their spin or charge states. Quantum dots can also be coupled with other quantum systems, such as photons or superconducting circuits, to create quantum networks. Challenges in using quantum dots. Some challenges in using quantum dots are toxicity. Some quantum dots are made of toxic materials, such as cadmium or lead, which can pose environmental and health risks if they leak or accumulate in living organisms. Therefore, there is a need to develop safer and biocompatible quantum dots or to find effective ways to prevent their release or degradation. Stability. Quantum dots are sensitive to oxygen, moisture, heat, and light, which can cause them to degrade or change their properties over time. Therefore, there is a need to improve the stability and durability of quantum dots or to find suitable encapsulation or protection methods. Fabrication. Quantum dots require precise control over their size, shape, composition, and surface chemistry to achieve the desired properties and performance. Therefore, there is a need to develop scalable and reproducible fabrication methods that can produce high-quality and uniform quantum dots with low cost and high yield. These are some of the main challenges in using quantum dots that are currently being addressed by researchers and developers. Quantum dots are a promising nanomaterial that could revolutionize many fields of science and technology.